Hello. So for our recording of 5.5, properties of logarithms, we will start out with a review from Algebra 2, okay? Review. The log of a product equals the sum of the logs. So what that means is log base A, if I were to multiply two things, for example, m times n, then according to this property, it should say that equals, it's kind of like adding the two logs. So that means I have log base A of m plus log base A of n. The log of a quotient equals the difference of the log. So if I have log base A of m divided by n, okay, now it equals the difference, meaning that I will subtract log base m, subtract log base A of m equals subtract log base A of n. So property number 3, the log of a power equals the product of the power and the log. So what that means is, and this is an important one, okay, log base A of m to some power, let's call it p, okay, power, equals, I'm going to multiply this power to my log. So p log base A of m. Okay. And remember, so now you have power, you multiply them. The change of base formula. If I give you log base A of m, the change of base formula, that means I can change it to a different base, any base you want, okay? Log, instead of log base A, let's call it log base B, of m divided by log base B of A. A is this right here, okay? So i.e., if I have log base 3 of 7, this is equivalent to, let's say I'm going to use common log. Log base 7 divided by log base 3. Or I can change it to natural log. That means it's the same as natural log of 7 divided by natural log of 3. Or I can change it to log base 5 of 7 divided by, log base 5 of 7 divided by log base 5 of 3. Notice how I can change any base I want as long as the ratio of the same new base, okay? So this b right here has to be the same for all of them, if you can see. So if they're both natural log, you keep natural log. If they're both common log, you use common log. And then this 7 has to be from here, and this 3 right here has to be from here. So with that said, okay, let's spell this out. Log base A of m, I will use natural log and common log to change it. The first one I'm going to use is common log. I can change it to common log of m divided by common log of A. I can also use natural log of m divided by natural log of A. So with a calculator, can you do me a favor? This is on your own, okay? So I would need for you to hit pause on your own, use the calculator and use a change of base, okay? If you have a new calculator, I don't want you to use the log base 589. I would like for you to use a change of base and plug it in for me and give me an answer, okay? The next few questions, it's asking us to prove, okay? Make sure you are listening and paying attention because it's really important that you understand why after this we would just use it. But for this particular video, we're going to see why it's always true. So prove that log base A, that means any base at all. It can be base 2 of 1, base 10 of 1, base 11 of 1. It's going to be 0. So let y equals log base A of 1. I'm going to write it in exponential form, okay? expo form. That means I have a to the y equals 1. Well, a is any base that you can use. Whatever the base is, you can, any base to a what equals 1 is really the question for it to be true. Therefore, y must be 0, okay? So we're going to check for a little bit. So, for example, log base 10 of 1. This is always going to be 0. And let's check. Okay, I'm going to rewrite it in expo form. 10 to the 0 equals question mark 1. Of course, check. Okay, so that's why this is always true. And this is the proof of why we can always use this. Okay, prove that log base a of a equals 1. So I'm going to write let log base a of a, instead of 1, I'm going to make it a y value, okay, equals y. Then I'm going to rewrite it in exponential form, expo. Then I'm going to have a to the y equals a. Well, this a doesn't have an exponent, so can I give it an exponent of 1? Of course. That has to be true. So therefore, y has to be 1. Okay? And this is always true. So I'm going to say, hey, so how about ln of e? Remember, ln of e, we said it equals to 1 because ln of e is log base e of e. Look at that. How about if I give you log base 5 of 5? From now on, you should know that this always equals to 1. Happy face. Because if I see this, I don't have to do any work. I just know that it's always 1. So, 2 things so far. Log base a of 1 is always 0. Log base a of a is always 1. How about if I have log base 7 of 7? It's 1. How about if I have log base 9 of 9? It's 1. Okay, 2 more proofs. Prove that a raised to the power of log base a of m is just simply m. Okay, so again, I'm going to let a raised to the power of log base a of m be a y value, whatever that is. Okay, and again, I'm just going to rewrite this as expo form. I'm sorry, not expo, it's already an expo. I want to rewrite it as log form. Okay, so log form says log, okay, this is my base a of y equals my exponent, which is this right here, exponents of a log base a of m. Whoa, log base a on the left, log base a on the right, they are identical. So therefore, y must be m because it's an equation. If it's an equation and you got log base a on the left and log base a on the right be equal, then y must be m, right? Y must be equal to m. So that is definitely true. So what do I do? What do I use this for? So if I give you this, 5 log base 5 of 6, what do you think the answer is? Did you say 6? Oh, thank you. That makes me so happy. Okay, how about if I have e to the n of 7? What is my answer? E to the n, okay? E to the n, or 5 to the log base 5, e to the n is the same as e to the log base e of 7. So guess what? The answer is 7. Okay, so from now on, if you understand these are the quick ways we can get answers. All right, last proof. Log base a of a to the power of r equals r. Okay, so again, I'm going to say let log base a of a to the r equals something like called y, not related to r yet, because we don't know. Then I'm going to rewrite this, okay? And let me remind you of what I'm going to use. See this property that we're using? Okay, log base a of m to a power of p. I can rewrite it as p times the log. So that's what I'm going to do. I'm going to bring this p power to the front, okay? So for our problem, I'm going to bring this right here to the front, okay? So I'm going to write r times log base a of a. And that still comes out to be y, because I'm not doing anything to the y yet. Well, what do you think? Log base a of a. Didn't we just prove that somewhere up here? Whoa, look at this. Okay, log base a of a is always 1. Oh my goodness, this is always 1. So now we have r times 1 equals y. That means r is y. Snap, okay? That means this is r is y. That means this is true, okay? So let's give us an example. Log base 4 of 4 to the 7th power. According to this theorem, log base a of the same number to the power, the answer is just going to be, guess what? 7, because these will cancel each other out. Isn't that beautiful? Okay, let's do example 1. Use the properties of logarithms to find the exact value each. And no, you may not use a calculator. It said so. So, ln of e to the power of 3rd root of 26. Wow, that looks scary. But ln of e is always 1. So in theory, if that's an exponent, you can use the multiplication rule. See this right here? When you have a power of a log, it becomes a multiplication. So I can write this power, bring it to the front, times ln of e. Well, ln of e, it's always 1. So my answer is just simply 3rd root of 26. Okay, so these kind of problems should be super easy. Okay. All right, I have multiplications of 2 logs. Let's check it out. I have log base 3 of 8 times the quantity of log base 8 of 9. You need to figure this out without a calculator. So the first thing I'm going to do is I'm going to, I want to make sure this is a multiplication of log. Okay. I'm going to see, because it's this whole thing, class, it's a multiplication of log. I can bring it back up as a power, okay, like this. Log base 8 of 9, because it's multiplication in front of log. I can use this as a power of log base 3 of 8. Isn't that trippy? Okay. Then from here, I'm going to write 9, okay? So log base 8, I'm using 9 as a 3 square. Oh my goodness. And 3 square, I'm going to, because that gives me 9, and I'm going to just copy down this log base. Let me box this up. This power in red. So that is raised to the power of log base 3 of 8 is going to be 2 to the 3rd. Oh my gosh, so many powers, okay? So Now, if you look at this, you have power to the power. I'm going to multiply these because this is just power to the power. So if I multiply those, so crazy, right? Then I have log base 8 of 3 to the power of 2 times log base 3 of 2 to the third. Okay, so carefully work this out. Then from here, if you check this out, do you see anything at all? Anything at all that we need to? Okay. What about anything that we need to do? Can I move this power up? Like, for example, this right here. Can I move this to over here, like square? Okay, I'm out of space. I'm going to move. So can I go log base 8 of 3? Okay. Now this is a power. See this right here? I'm going to use this as a color right here. I'm going to work with this. So see how that's 2 times? Okay. I'm going to rewrite it as a log base 3 of 2 to the third to the square. Can you see it? So I'm moving this right here back up here. Okay. Then from here, I'm going to, guess what should I do? Can we do anything from here? Power to the power, can I multiply those? Crazy, right? All of this. Log base 8, this is just manipulation of log. Okay, so base 3 of 2 to the power to the power and multiply. So can I get 6? Okay. But here's a beautiful piece. Can I highlight this for you? 3 to the log base 3. Can you tell me what it is? 3 to the log base 3. Can you tell me what it is? I'm going to move up a little bit just to kind of remind you, okay? Does this right here indicate something at all? 3 to the log base 3 equals 3 to the log base 3 of m equals m, right? Well, I have 3 to the log base 3 of 2 to the 6. So guess what? This is now log base 8. Whoa, 2 to the 6. Well, 2 to the 6 is 64. So now I have log base 8 of 64. Well, 64 is really, let's write 64 first. 64. Well, 64 is really 8 squared. Whoa, right? Well, let's go a little bit further. Can I move this back up? Here's what I want you to find for me. See this right here? Log base 8 of 8. Does that remind you of any one of these proofs? Okay. Log base 8 of 8. Okay. Log base 8 of 8 is what? Is 1, right? But I have this power, so I can move it to the front. So this is really 2 times log base 8 of 8. But log base 8 of 8 is 1. So this is 2 times 1. So all of that is just going to be 2. Yay! Okay, that's crazy. Okay, all right. Letter E. I'm saying letter C. See this right here? This I will give you. I know I don't give you too many extra credit. I'm going to give you an extra credit. Okay? Extra credit. I want you to do it and come and check with me. The first few people that turned it in will get extra credit. But remember, you have to get it right, and you have to be the first few. How about we take the first, let me see, the first 5 students, okay? How about that? First 5 students, that's a great one. So first 5 students that come and show me with the correct answer and work and able to explain it to me. You don't have to explain it in front of class, but explain it to me, then I will give you extra credit. Okay, adios.